All right, we're going to do this again. Hi, my name is John. This is really an awesome conference. I want to first of all say thank you very much for inviting me out here to speak. I'm from a small town a couple hours away that I'll talk about in a bit. But I'm going to start out with this title, Building Serverless Software with AWS Lambda. So I'm going to start with a little kind of dive into what serverless is. Has anybody heard of serverless? You probably see it with air quotes as well, right? So are there any like DevOps kind of people here? And they probably have seen serverless, and they probably have some thoughts on it, right? So what is serverless, right? And you're probably looking around the room. Like, I don't know, this serverless thing, I don't get it, but it sounds really cool and everybody's talking about it. And the DevOps engineers in the room are like, yeah, okay, serverless, ha ha ha. Yeah. Like, it's still on a server, duh. Okay, so here's the punchline. Serverless, it's a buzzword, okay? So we're just gonna take that part of it and we're gonna set it aside and we're gonna talk about kind of the methodologies that are going on along with it. Because guess what? Serverless is the future, right? At least according to this conference that occurred about a month ago. So serverless is what does it actually mean? Well, there's a very good quote, I guess. I took it from a blog post from this development engineer, Charity Majors, who's actually talking about giving her presentation or her hesitation at wanting to give a presentation at the aforementioned conference. Because there's a lot of talent and skill and knowledge that goes into being an operations engineer. And to kind of mask it behind this thing called serverless and like, hey, it's really easy now to just throw your code up and it just runs and you don't have to worry about it and it's scalable instantly. It doesn't really do it justice. But one of the positives that can come out of this thing, in her first or second blog post on the subject, she says, you can think of it as you get to rent engineers from Google, AWS, PagerDuty, Pingdom, and Heroku for a lot cheaper than if you could hire them in-house. If you could even get them, which you probably can't because tech talent is scarce. As seen by our job board out here that has a lot more companies looking for positions than people looking for companies. But she continues, on the flip side of this, application engineers need to get better at thinking in traditionally operations-oriented ways about reliability, architecture, instrumentation, visibility, security, and storage, right? So with great power comes great responsibility. Hi, I'm John. I work at a company called Coffee and Code, where I am one of three. I started the company about a decade ago, and we build custom software applications, usually with web technologies. And I'm going to take you on a little bit of a journey on how I got to using serverless kind of in my industry. So I'm going to take, I don't know how long you've been doing web development, but if you can kind of look back, at least into my career, do you remember when things were really easy? Oh man, that was so great, right? You have like an FTP client, you probably didn't have Transmit or CyberDuck, but you had something else and it looked really bad, but its only purpose was to take these small HTML and CSS and maybe a DHTML JavaScript file and put them on a server somewhere, and you look at it in a browser and you see it and it's done. And you're like, if you want to make a change, you just edit a file and you upload it and you see the results. It was perfect, right? It was great to be a developer then. But what happens a little bit over time? You're probably on some shared hosting solution and things just got a little bit slow over time. So your small application might not take up a lot of resources, but somebody else's horribly crafted PHP turd probably did. Nothing against PHP, it's an amazing thing. Thank you very much to the first speaker. The collect library looks awesome. So what do? You're like, I can't stick around here. I can't pay these people $5 a month with this kind of service. So you start to branch out and maybe learn a couple more things. So we want to start taking more and more ownership of our own environments. And we find some amazing applications and software that can allow us to create these more intricate architected solutions that we can own from end to end. So this is just a small smattering of the things that I've been learning just probably over the past couple years. And it's really easy to get interested in this joy of learning and creating things. And one of these technologies will easily lead to 1 or 3 more, and you keep learning and finding new things that you don't know. But I caught myself doing this quite a bit. And while I've learned all these applications over time, I don't know necessarily if this collection of things produces a better outcome for every single situation that my clients are in. They don't care if I have a Vagrant box. They don't care how I'm provisioning these services. They want to know, how do you get this thing out there? How do you adapt to changes that I request? And how do I never have to think about this? So I ask you, can we make this easier? Well, the easy answer is, the blatant answer, if you look at our previous history, cloud computing is very popular now. There's very little resistance in taking advantage of hosted servers on AWS, DigitalOcean, Azure, Linode. Iron.io is in here as well for a couple different solutions that they provide. So we've been outsourcing our hosting for years, right? So leveraging cloud hosting services from these different companies. But having access to a server still leaves a lot of leeway up to your application's architecture and the things that support it. So the thing that I'm going to be talking about today are how do we use specific services provided by Iron.io, Azure, and AWS to provide hyper-specialized miniature applications that are event-driven, asynchronous, and can be accessed by HTTP endpoints. So this is the big crux of my talk today. It's going to be around Lambda. It's actually going to be about how we utilize Lambda on a specific project. I'm going to talk about a couple of the technologies that are there to help you do this and support your code base to try and make it easier for you. And I'm going to talk about a couple other use cases as well. Because it's not Lambda that's the interesting thing. It's this concept of how do I make something not as complicated as I used to? How do I take an easy concept that I have and maybe only pay for the time that I'm utilizing? I don't have to manage these servers. I want to write applications. I don't want to watch log files. So Lambda is going to run in response to events. Those you can trigger yourself manually. They can also be kicked off from changes in an S3 bucket, as in adding a file, deleting a file. Changes to a DynamoDB or Kinesis stream, which are a couple data storage options on AWS, or in response to SNS notifications, which is kind of like a push notification that AWS provides. You can also integrate with the API gateway on AWS. So Lambda itself is just this chunk of code that runs, and it takes in some variables, and it returns some kind of a response. And if you pair this up with something like API gateway from AWS, that's when you have this HTTP endpoint, like a webhook kind of thing, right? So you can send information to a URL, you can have your code run in response, and send back a message. Lambda is going to run Node, Java, or Python natively. They're going to run some old versions of that stuff. AWS is very slow to adopt some changes, but that doesn't mean that you're stuck there. You can actually run any kind of binary that you can push up to this server, basically, that's running out there. And somebody's actually created a Docker application to try and make that process a little bit easier. I forget the distro that's actually running these Lambda processes, but if you can build and compile your dependencies, or maybe even like the binary that runs them, it doesn't have to be Python and Node and Java that is the code that is running out there on the server. It could just be Python, Node, or Java that bootstrap your application and kick it off. So another perk of Lambda is it has automatic scaling and fault tolerance. So this HTTP endpoint is not just one server, but it's a whole bunch of them that are back there waiting for you, and you only get billed when they get utilized. Okay, so the project that I'm going to talk about today is called Disclosure Quest. You can get to it at disclosurequest.com. But before it was disclosurequest.com, it was an idea that a guy came to us with, and he said, hey, I want to create a custom search interface to the SEC's Reg A, Form C, and Form D filing information. And I said, I don't know what any of those things are, but I could probably help you out a little bit. So what we ended up having to do is parsing HTML and XML pages from this SEC database of information. I'll tell you why it was in HTML and XML form in a sec. We wanted to avoid IP traffic restrictions because this service that we're going to be consuming information from is going to shut us down if we make too many simultaneous requests. So we need to take a lot of information and we need to do it in a way that plays nice in their environment and make sure that we can end up getting all the processing done that we want to have. We're going to store this information for searching, and we're going to archive the files off to S3. So Edgar, or sorry, the SEC has this system, it's called Edgar. Does anybody work for the SEC? It's a lovely piece of software that was put in place, I don't know when, but I'm going to guess before any of us were born. And it hasn't been updated since. So there's no API, there's no way to get information nicely out of this system. You have to scrape web pages. You have to go somewhere, find some kind of identifier that points you to another page and pull information out. And then you have to figure out how you're going to manage that information yourself and maybe even archive it just in case their system goes down. Their actual site closes, it just shuts down outside of, I think, 9 to 10 p.m. or something, like 9 a.m. to 10 p.m., Monday through Friday. It's just off, like you can't use it. You can't, it's just, it was a fun, challenging problem, right? So we're like, all right, so how are we going to get all this information out of this system that we can kind of get to, that is going to get temperamental and is probably going to fight back with us, right? And so at first, when I had this giant toolbox full of things, I might go, oh, I got the idea. I have the answer. We're just going to Rails all the things, right? Rails will do this. Like, I just need to render some pages and run some background jobs and scrape some information and blah, 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 whatever. We'll do it all, right? But I got to think about how am I going to avoid these IP restrictions? I just can't scrape all the information. I need to think a little bit differently about it. Oh, and then we're going to have this server that the client has to manage and maintain over time. Oh, they're not technical in nature, so they're not going to know what to do if something bad happens. Oh, and all these libraries go out of date, so then we're going to have vulnerability issues on the server. So what do we want to do? We want to take a step back, and we want to say, all right, we know what the problem is that we're trying to solve. How are we going to get to it in a way that solves the problem, which I think we can all do, no problem. But how do we do it in a way that the deliverables are going to be aligned with what the client is actually asking for implicitly? So we're going to want to know when errors occur. If any problem occurs during the parsing of information, I want to know about it. Is something going bad on the other side? Is something going bad in our code? Have they changed something, right? They're not publishing spec, well, actually, that is unfair. They publish PDF spec changes. But I'm not going to read them all, unless I'm paid to read them all. We have to handle these spikes in traffic. If this website blows up, that's awesome. I want it to blow up. I want to get it on the front page of every crowdfunding website. But I don't want some kind of a parsing error to take down our site. And I don't want our site to take down our parser. So we kind of have these two separate pieces that I'm going to have to start to build. We need to avoid these IP blacklisting and play nice with their servers, right? And I want a small and focused code base that's easy to maintain. Okay, so how are we going to do this? This is at least how we did it. We had Lambda, which is going to handle background and async job processing. I'll talk a little bit more about the two parts, the processor, or the parsing, and the website. But overall, we're going to involve these pieces. We're going to take ElasticSearch. I don't know if you got to mess with ElasticSearch yet. It's an amazing, it's fun. It's a joy of a search kind of engine, database, hybrid, weird thing that takes a lot of reading to kind of understand. But it's sweet. It's awesome. And what it does provide is a RESTful API that you can get information out of your system with. And it's also going to do fuzzy text searching right out of the box. So when somebody types a name incorrectly and they still want those results back because we live in the age of Google, they're going to be okay. We're going to use S3 to do our storage and persistent data storage. So all of these filings that go off to the SEC are going to have like a small tidbit of information that's parsable that we want to be able to search off of. And they're going to have a lot of information about like a giant PDF that got filed that has all of the text and information from the submission. We're going to use SES. So they want to have a contact form on the page that says, hey, we're new, we're in beta. If you find something that's weird or you have some features, let us know, right? But I don't want to manage some server that has to take care of that. So we're going to handle SES to be able to send off these transactional email requests. We're going to handle a queuing of information with SQS. That'll be a little bit more, I'll explain in a bit. CloudWatch is going to handle some logging and monitoring, but I'm also going to implement or put on the server rollbar, and it's just one of many error catching as a service services that you basically pay for, and will alert your developers and say, you screwed up, go fix this thing. And in our case, we're going to use DigitalOcean for hosting the public website portion. All right, so we have a data parser. By now, you might have been thinking a little bit like, all right, I understand this problem. How am I going to get to this stuff, right? So in our case, we have to go to some web page or an RSS feed or something like that that gives us newish results. We need to be able to scrape all of the higher level identifiers off so that we can make subsequent requests later on. And we're going to take all that information and we're going to pump it over to queues, SQS. So this queue is basically just going to hold this giant list of identifiers. Okay? And what this allows us to do is this first part of the parser is very quick. All it does is say, give me all you got, I'll put it on the queue. Give me all you got, I'll put it on the queue. I don't do all the work at one time, because if you do that, how many requests are you going to open up? How many filings do you have to download? How many things are you going to churn through? I don't want to handle all of that. And you can kick it over to something like SNS, which is this kind of like more immediate push notification, but I want to control the speed at which I am taking things off of this queue and further processing them. So in this case, all I'm going to do is take my information, kick it over to SQS. And there's this very simple Lambda job, and it's going to get kicked off by cron, so it's some kind of a scheduled time. And we're just going to say, hey, every X number of minutes, these days of the week, I want you to do the one job that I told you how to do. Right? And so the code to do that task is very small, and somebody can look at it and understand what it does. There's a second part to this data parsing, and that's when this information is in SQS, what do you do with it? Well, we made a couple other jobs. And what we're going to do is its sole purpose is to talk to a queue and say, do you have anything for me? No? Okay, I'll come back. Do you have anything for me? No? Okay, I'll come back. Yes, you do have something. Great. What I'm going to do is take this identifier information that you published to the queue, and I'm going to go back to Edgar, and I'm going to say, give me all you got. I'm going to take the information back. I'm going to start streaming files off to S3, and I'm going to take the parsable XML file that I get from them, and I'm going to transform it and modify it into the format that we need it to be in, and we're going to shuttle it off to ElasticSearch, and it's going to only handle a couple items on the queue at a time. Right? And I am in charge of saying how many items you're going to pull from that queue, how many of these jobs they're actually running. You can run as many jobs from the same queue that you want. Right? So what happened is when we did the initial work for reading latest filings, right, there's maybe only a couple hundred that come through a day. But when you look back at past history, there are thousands and thousands and thousands. How do you manage all of that? Well, you shove it in a big queue and you fire up like 20 Lambda jobs, and they all do the same thing, and they all work off the same code base, and they're not going to stomp on each other. So this data parsing is 5 things. It's going to have that first job that runs every 5 minutes. It's going to request new filings from Edgar, parse the results, and enqueue that identifier for later processing. It's then going to have these secondary jobs that are going to process and via cron and pull items in for further processing. And the resulting information sent to ElasticSearch and S3 will pop the items off of the queue so that they don't get processed again. And any kind of errors that happen along this process, we're going to be notified through this error service roll bar in our use case. And like I said, you can have as many of these job processors or as few as you want. You can just log into AWS and change the schedule on how often they run. You could just hit the disable button and turn them off if you run into some weird issue and something big has to change before you can kind of continue processing. And it all works on its own. We don't have to touch this thing, right? The only thing that could go out of date are the libraries that we have to use. So we used a couple of NPM libraries that might turn out to have some kind of a security vulnerability, and the code that we write ourselves. The operating system part, we never touch it, we never have to see it, we never have to care about it. Well, that's a lie. We do have to care about it, but it's a little bit different than if we brought up the server ourselves. So then on the website side, well, what do we have to do? I'm going to request information from Elasticsearch. I'm going to render HTML pages. That's it. You probably think of a whole ton of hosting solutions that'll do that, a whole ton of libraries that'll allow you to do that. All you're doing is making some kind of an authenticated request over to Elasticsearch. You're saying, give me the information based on the query that I received from the user, and I want you to render this HTML page and send it back to them. So since we have the API requesting information from, all we're doing is this extremely simple job over on the website side. We can smash the server and turn it off. We could bring back more. We could throw a couple behind load balancers. We can throw them on different hosting environments. If they bring in some other developer that wants to render this stuff in some other application and they want to use something and they don't like Node, that's fine. It's very simple. There's no data processing. There's no data persistence that's going on in this server. This part's completely autonomous from that parser that we wrote originally. So I want you to think about complicated setup and management and how it possibly puts undue burden on the client and their team. So how do you limit the maintenance that's required for these projects that you're delivering? And what needs to be managed for the continued health of your application? So in our case, we got a success. The client was happy, it did what it needed to do. There's a lot of work that was going on that we didn't necessarily have to write the code for. And there's a lot of services that are out there. You don't have to use AWS. There's a lot of really great things that you can utilize if they make sense for your problem set. So some other examples, if you're going to work with Lambda, is maybe using API Gateway to handle your HTML form submissions. So our website at Coffee and Code is a static page because I got really tired of just weird hosting stuff, right? Site's not that crazy, it's not dynamic. I just want to show some content, show some portfolio pieces. I don't want to worry about security hacks and all that crazy stuff. So we host a static version of our site. Static versions are awesome. However, when you want to do something dynamic, like capture a contact form request, what do? Well, you could Rails all the things, and now you have this, you have this other server that's running that you now have to care about 24/7. When really all you care about is the maybe 3 seconds that it takes for a user to submit a form and for some kind of magic to occur on the back end, right? So what we use is an API gateway endpoint. We do form submission, just a normal HTML form submission. It sends the data there. We process it lightly in API Gateway. It gets sent over to Lambda. Lambda says, hey, do you have the Google reCAPTCHA token so this person isn't spam? Yep, cool. All right, we'll let them through. And we're going to send this information over into your CRM system, and we'll send an email out to your team to let them know that there's a new contact information to chat with. Right? I don't want to manage a server to handle email requests. I'm going to guess that a lot of you don't either. You could also recreate maybe a website or some publicly accessible or even IP-restricted resource every X days or minutes or hours. Maybe you have a company dashboard that you're showing on a computer somewhere, maybe on like a screen in your company. What if you're pulling information maybe from a couple third-party APIs and you want to aggregate that information, render it into some static HTML, and then send that off to somewhere like an S3 bucket that you can hit with a web endpoint. But you don't want to have a server up there to be managing it, or you don't want to kick something off from your development machine every month or something like that to update the numbers. You could put this thing on a cron job and in Lambda and never think about it again. Or maybe you have an application that does A, and you have these partners or third-party vendors that come in that now want this weird data transformation that needs to occur, maybe only at one point, or maybe only for like these weird edge cases. And you can suck that stuff into your code base, and you can run some delayed jobs, and you can do data transformation however it makes sense. But if it's going to produce more cruft and maybe distract you from what your original application is doing, is it maybe something to look into to have this smaller subset of code that its only job is to transform data from the way that your vendor has it into the way that your system ingests it, and then send it off to somewhere for later processing. You could also set up these HTTP endpoints to listen in response to API webhooks and maybe send something off. So if you have a Stripe account, you can set up this endpoint to listen to notifications that come back in, and maybe depending on the context that they receive, to go ahead and send a message to your Slack channel, send an email to your users or your developers. There's a lot of things that you can do when you only require on-demand processing. So the tooling for this, if you start Googling, you're going to probably run into this right away. It's serverless. It's called serverless. It's built in Node. If you're going to be developing in JavaScript, you're probably going to run along this direction. It's an awesome library, and what it tries to do is produce a bit of a project template that you can put your code in, and then say what kind of API endpoints you're going to want, and then what kind of Lambda functions, which could be multiple, that you're going to want to deploy. My only caveat here is a little bit of a buyer beware. They are moving rapidly. They are just throwing tons of changes in there. It's going to be an amazing product, and I use it now, and it's not that it's not good now, but it is changing quite a bit. So if you're thinking that you're going to be able to put something in place and then walk away from it, you might have to kind of watch it a little bit more than that. This is just a response from one of the plugin authors who was getting a little bit behind on being able to keep his plugin up to date because the core serverless project was just changing so rapidly. But if you're not into that, or you're maybe into some other languages, there's a lot of other options that are available. Apex is for deploying Go applications. So if you're more of a Go guy or girl, you can go ahead and check out Apex. It's going to focus on solely the Lambda part, which is good. I think focusing on one thing and doing it very well, it makes it a lot easier to kind of get introduced to the tooling. There's also Zappa and Gordon, which are both using Python. And Gordon is specifically using CloudFormation, which if you used AWS, if you want basically a template of what your application looks like, and you can kind of make changes over time, CloudFormation is its kind of template files, but nobody likes using them, so everybody builds these weird abstract tools around them. And then you could also look at comparative services if you don't like AWS or you're looking for something else. Iron.io has actually been around for a while. That's what I wrote our original website's contact form HTTP endpoint thing with. So they have a queue system, they have a caching service, and distributed job processing. And then Microsoft Azure has also come out with these kind of event-driven tasks that you can run inside of their environment. So a couple lessons learned. Log vigorously. So it's one thing when you have your giant Rails application that shoves all your logs into one location and you can go and check it and you know where everything's at. When you start to depend on other people's architecture and other people's uptime and how this environment is playing nicely or not nicely with your code, you're just going to want to make sure you can figure out where the mishaps are. So Lambda really easily syncs up with CloudWatch on AWS. So just make sure that you log things. Actually take time to think about, are we logging everything that we need to have access to if something goes wrong? I would recommend using an error notification service. You can also set up alerts with CloudWatch to just search for certain strings in your logs and go ahead and handle that for you automatically, so you don't have to pay somebody else to maybe watch your exceptions. API gateway is cool. It sounds really great. It's also really, really, really frustrating because it's very newish, and AWS decided that they want it to work well with JSON endpoints, and that's about it. So you kind of have to jump through a lot of hoops to do non-JSON stuff. But I would imagine it gets better over time. You can also use Swagger definition files with API Gateway. So if you're trying to make some kind of an easy way to generate code or generate documentation around what your API should be, feel free. You can create API Gateway projects with Swagger files. You can also export Swagger from API Gateway if you use their kind of GUI interface. And I would just say try to think about your application as these distinct parts, if possible. And if you're on the AWS side, you're just going to want to make sure that you know how to use their rules and permissions side called IAM, because what's going to happen when a Lambda function runs, you will tell it what it has permission to. And I would recommend that you don't tell it has permission to everything in your system. You probably want to say, all right, I need read access to this, and I need write access to this. So there's a couple of resources here. You probably can't read the URLs, so I'm just going to read through them real quick. If you Google awesome and then another word, you start to run into these GitHub README files that just have a ton of links. So I would check that out. There's one called Awesome Serverless. It's really helpful when you're trying to learn something new to kind of see what else is out there instead of hope that you kind of trample onto something that would help your experience. The second one is the link to the blog post from the author in the beginning. Serverless.com is the serverless node library. At Copying Code, we wrote a small GitHub project called AWS Auth Helper that helps to try and do two-factor authentication with serverless deploys. And then whatdoesLambdaSupport.com gives you insight into what JavaScript features are supported in each runtime. Sorry, that was a lot. But if you have any questions, I will be around. I will be at the party tonight. And I hope that you can maybe start to think about your applications a little bit differently, or at least kind of the solutions that you're delivering to your projects. Thank you.